Hi everyone. So last time that we discussed is all about an ideal gas, which means that we are only dealing with uh, on how we describe the properties on a certain point of state on a particular gas. But this time we discuss a process of a certain gas, which means that we we calculate or we describe from the initial point of a state to the final point of a state. So, but before that, let us define what is a process of ideal gas. So, thermodynamic process is a passage of the thermodynamic system from initial to a final state of thermodynamic equilibrium. So the initial and final states are defining elements of the process. So passage, which means path of the processes from the initial point of state to the final point of state. So ato i-calculate or ato i-describe unsay nahitabo sa processes from initial point to the final point of state. So there are um, five kinds of processes, no. So karon ato lang i-discuss is ang tulo lang usa ka processes. So ang control no constant volume process or and uh, so, and isobaric process and isothermal process. Okay, so mag-una sa constant volume process. So constant volume process, or what we call isometric or isochoric process, is a reversible constant volume process. A constant volume process may be reversible or irreversible. So kung moingon kay tag reversible, so ang imuhang kuan ana, ang imuhang gasa na is mubalik kung nay mahitabo nga processes, so mobalik siya into initial point of state. So ang irreversible pod kay dili na mo balik, or it will never back to initial point of state niya. So as we observe this figure kana, kung moingon tag constant volume process, so ang ihang body na is a rigid. Kung ato ning i-observe this figure, so if we apply this heat or Q, so which means that kaning nga body is, or kaning nga boundary is rigid. So walay nahitabo nga moving boundary ani. So ang iyahang interaction ani is it only a internal energy. If we apply a heat ani, so ang iyang pag-increase ra ang iyang internal energy. So kung mogamit ta og first law of thermodynamics, so ang Q niya ni is equal sa the changing of internal energy. So we have a typical figure for this, for constant volume. So as we observe this figure, kung apply tag heat nya, rigid body siya. So the more nga mag-apply tag heat, kay tungod constant volume man siya or rigid body, so ang iyang pressure is mo increase. Okay? So kung ato na i-graph in terms of PV diagram and TS diagram, or what we call pressure volume diagram, so mo ni mahitabo or ma-describe sa iyahang process for this constant volume process. So we have P and V, yan, and then at initial point, so what we call a point 1, and then the final state is a point 2. So kung ato to i-describe, ang nahitabo atong sa katong figure, so from point 1, so ni-increase ang iyang pressure. So mo nang into point 2. So this is pressure 1 and this is a pressure 2. Okay? So in terms of TS diagram or temperature entropy diagram, so mo ni mahitabo sa iyang behavior sa atong processes. So kana. So in terms of point 1, the mo ni ang temperature 1. Then in terms of point 2 is mo ni ang temperature. In the area under the curve, kani siya. So kung ato ni calculate ang area under the curve, so ang ato makuha na is ang iyahang heat of the processes, this constant volume process. So in relation between P or pressure and temperature, so di na ta mag-deal ani sa iyahang volume kay which means ang ang iyahang kuana ni volume is unremained change man. So from this relation, these processes, so T2 over T1 is equals to P2 over P1 accordance with the isa siya Charles law nga sa ideal gas. And then the non-flow, so non-flow work, so kung mag-calculate kita sa yung work ani these processes, so ara gid ta mag base in terms of pressure volume diagram. So kung ato ni as we observe this pressure volume, so uh, walay area nga nakiter ani no sa kaning nga diagram, kay it only vertical raman ang iyang behavior sa iyang pressure volume. So walay nahitabo nga area ani. So ang iyang work non-flow is equals to integration of PdV is equals to 0. So ma-zero ang iyang non-flow work. So what do you mean non-flow? The non-flow process, it is the one in which there is no mass interaction across the system boundaries during the occurrence of process. Kung maingon ka no mass of interaction, so sa imong body ana is a moving boundary. So which means dili na siya control volume ang imuhang body. So if we calculate the change of internal energy, so the change of U is equals to the mass times the specific heat in terms of constant volume times the changing of temperature or T2 minus T1. In the change of enthalpy, which means change of H is equals to MCP T2 minus T1. Okay. So if we calculate the change of entropy, as we observe this diagram, this diagram, the kaning pagkuha ng Q is kanang directly proportionality sa iyahang changing of entropy. So kung ato na ikuan uh, i in terms of mathematical form, so the ds is equal to dq over the temperature. So which means ang iyang changing of entropy is mag-agad ra gyud na sa changing pud sa iyang heat indirect inverse directly sa iyahang temperature. So if we apply integration for this, so ds is equals to integration of, so ang ato ang changing of heat is equivalent to mcb changing of dt over t with respect to t. So kung ato ni integrate, so mo ni ang ma-form sa iyang mathematical form. So change change of s is equals to mcv ln. So dt, integration of dt over t is equivalent to ln t, di ba? So upper limit minus lower limit mcb ln t2 minus ln t1. So para ato i-simplify, so nga ang may tabo sa iyang formula. So change of S or change of entropy is equals to mcb ln t2 over t1. So for the reversible steady flow constant volume, so if we apply first law of thermodynamics, so mo niyang may tabo sa iyang equation. So the Q is equals to change of U or the changing of internal energy plus change of kinetic energy plus the change of workflow plus work steady flow plus the change of potential energy. So if we cancel the Q is equals to change of U, so mo na lang niya may bilin for cancellation. So assuming that there is no velocity and there's no elevation for this kaning situation. So the change of T niya is equivalent to 0 and then the change of P is equivalent to 0. So ang mabilin is ang work steady flow is equals to negative change of workflow. So no need na ta nag-cancel ta sa Q in the change of U. No need naman ta mag-apply og kanang heat. So ato ang gi rani, ang ato ang gi studyhan lang ani is ang iyang workflow. So work steady flow is equals to negative V times P2 minus P1 or equivalent to work steady flow is equals to V times P1 minus P2. In irreversible uh, non-flow constant volume process, so Q is equals to change of U plus work non-flow. So kung walay non-flow nga mahitabo, so ang Q nimo is equivalent to change of U. So let us have an example. Sample problem number 1. Sample problem number 1. So 10 cubic feet of air at 300 psi and 400 degrees Fahrenheit is cooled to 140 degrees Fahrenheit at constant volume. What are, so A, the final pressure, in the B, the work, C, the change of internal energy, in D, the transfer heat, in E, the change of enthalpy, and F, the change of entropy. So first, we calculate sa A nga questions. Sa A is the final pressure ang gipangita. So we have this relation between P and P, no, sa constant volume process. So sa P2 over P1 is equals to P2 over P1. So sa diri nga given problem na natay temperature 1, pressure 1, and temperature 2. So ang gipangita ni is ang final pressure or the pressure 2. So if we perform this relation, kani nga formula dapat i-absolute temperature nato and absolute pressure nato. Sakto. So T2 na to is 140 degrees Fahrenheit. So 140 plus 460 in terms of Rankine. And then 400 the temperature 1, 400 plus 460 degrees. So in terms of Rankine is equals to pressure 2 over the 300 psi. So pila na siya? So 140 plus 460 all over 400 plus 460. Then times 300. So the answer is 209. So 209.30 psi. And then B, the work. So sa kaninga process is ang work niya in terms of 0, which means the non-flow is, because non-flow is kuan man na siya rigid body, so which means it is kuan kanang fix nga boundary. So walay mahitabo nga changing of volume niya. So wala say mahitabo nga work. So ang work niya is equivalent to 0. So sa C, the change of internal energy. So we have this formula. Change of U is equals to mcb T2 minus T1. So we have temperature 2, temperature 1. So ato ang problema na lang is ang mass niya and then the specific heat in terms of constant volume. So in order to get the mass, so we have to perform PV-MRT or an ideal gas equation state. So PV is equals to MRT. So we have volume and we have pressure na pod in terms of state 1 or initial state, and we have temperature 1. So PV is equals to MRT 300 psi A. So para mabalance ang imuhang unit, so in terms na to feet tanan. So this is 300 psi A or pounds per inches squared. So in terms na to feet squared. So ang equivalent sa inches squared to feet squared is equals to 144 times 10 cubic feet is equals to mass times 53.3 or lb feet per lb feet per lb Rankine times 400 plus 460 Rankine. So the equivalent mass is equals to 300 times 144 times 10 alpha equals alpha x times 53.3 times 400 plus 460. So the answer is 9.42 pounds. So 9.42 pounds. So atong formula sad sa constant specific heat in terms of constant volume, we have R over K minus 1. So ato na ning na discuss na last time sa kaning formula. So atong CB is equals to 53.3 over 1.4 minus 1. So kung ato na i-calculate, so the answer is 133.21. So the change of internal energy, we have 9.42 times 133.25 times 600 minus 860. So the answer is negative 326.335.9, or in terms of BTU. So i-convert na to in terms of BTU. We have 778. In 1 BTU, we have 778 feet LB. So the answer in terms of BTU is negative 400.48 BTU. So sa ato ang applying sa first law of thermodynamics, so wala may moving boundary, so walay change of enthalpy pod. So ang pag-apply ani sa iyang first law of thermodynamics, so ang iyang Q ani is equivalent ra in terms of change of U. So the Q is mo gyapon ang value negative 409.48 BTU. So next, we have change of H. So for change of H, so nakalihan lang atong sa change of internal energy ang iyang specific heat. So atong gamiton nga specific heat sa in terms of enthalpy, change of enthalpy is naka constant pressure siya. So the formula of constant specific heat in terms of constant pressure is equals to RK over K minus 1. So we have gas constant in terms of English system 53.3 and 1.4 over 1.4 minus 1. The specific heat ratio, equivalent sa specific heat ratio sa air is 1.4. So we have 186.55 feet pound per pound Rankine. So na naman tayo mass, ato na nakuha. Then nakuha na po na to ang CP. So we can perform the change of H, or we can get the value of change of enthalpy. So the change of enthalpy is equivalent to negative 456.898.26, or in terms of BTU, we have negative 582.27 BTU. So for that F, change of S ang gipangita niya. So how we get this value? So from atong na derive ganiha sa atong discussion, that ang change of S na today is equivalent to MCB ln T2 over T1. So we have mass and we have TB na pod. So 9.42 times 133.25 ln 600 over 860. So, pila na siya? So, 9.42 times 133.25 times ln 600 over 860. So, we have negative 451.88 LV per Rankine. So, in terms of BTU per Rankine, we have 0.581 BTU per Rankine. So, ito i-divide. Divide 778. So, muna siya 0.581. Negative 0.581 BTU per Rankine. So, now, let us move to isobaric process or constant pressure process. So, an isobaric process is an internally reversible process of a substance during which the pressure remains constant. So, an isobaric process is a thermodynamic process in which the pressure remains constant. This is usually obtained by allowing the volume to expand or contract in such a way to apply a heat. So, as we observe this figure, image, so kung ato ni vice versa ang kaninga process, in order to maintain a pressure, so dapat mag-increase pud ta sa iyahang volume if we apply a heat. So para ma-maintain ang iyang pressure, dapat increase pud nato ang iyang volume ani. So if you have a cylinder with a weighted piston and you heat the gas in it, the gas expands the due to the increase in energy. So this is in accordance with Charles' law. The volume of a gas is proportional to its temperature. Kung i-maintain na to o i-prevent na to increase the pressure. So dapat i-increase na to ang iyahang volume. Wala siya. So kung ato na describe ang iyahang processes. So we can describe by using a PV diagram. By using a PV diagram, which means at initial point 1 or initial state, so mo ni siya mahitabo. But we have a process, we apply heat, so naay final state ang usa ka behavior sa usa in a certain gas. So at point 1, so mo ni siya mo ni ang volume 1 or initial volume. In a point 2, mo ni ang final volume. So as we observe that this graph, so maka-create tag area sa kaning PV diagram. So the area under this curve is mo na iyang work pod or equivalent to the integration of PdV. So if we apply kaning saan siya? If we apply integration, so we have integration of PdV or that the pressure times the changing of the volume niya. So mo na yang changing of work pod sa usa ka process. So in terms of TS diagram, or temperature enthalpy diagram. So we have this point 1, this initial state, and then this final state. So we have this. So at point 1, we have temperature 1, kani, and then temperature 2. So the area under this curve for this TS diagram is equivalent to heat niya. Okay. So in relation between V and T, we have V1 over T1 is equals to V2 over T2. So in reference na sa Charles law, no? And then the non-flow work. So we have this work non-flow is integration from 2 to 1 PdB is equivalent to P V2 minus V1. So makuha na nato ang work ato. So mo ay nakalian sa isobaric process ug isometric process. So ang isometric process, ang iyang work non-flow is equivalent to 0, which means ang iyang body is rigid. So kaning isa moving boundary naman ang kaning nga process in terms of isobaric process. So the change of internal energy for this, we have mo gyapon MCB to minus T1, and the change of enthalpy, we have MCP T2 minus T1, and the change of entropy, we have MCP ln T2 over T1. So nakalayan atong sa isometric, ang gigamit niya nga specific heat is in terms of constant volume. So sa isobaric process is in terms of constant pressure. So okay. So let us have an example. So sample problem number 1. So a certain gas with CP 0.529 BTU per pound Rankine and R is equals to 96.2 feet LB per LB Rankine expand from 5 cubic feet and 80 degrees Fahrenheit to 15 cubic feet while the pressure remains constant at 15.5 psia or pounds per inches squared. So compute the temperature 2, and B, the change of enthalpy, and C, the change of internal energy, and D, the change of entropy, and E, for an internal reversible non-flow process, what is the work? So, saan pa dapat? Yan. So, solution. So, for A, so, atong gamiton ng relation between V and T. So, we have this formula. So, in Charles law nga equation. So, T2 over T1 is equals to V2 over V1. So, ato i-substitute, we have this given problem kaning sa V2 ug sa V1. So, nanaputay temperature 1. We have this volume 1, volume 2, 15 cubic feet, and then the volume 1 is 5 cubic feet. And then the temperature 1, ilan mo siya? We have 80 degrees Fahrenheit. So in terms of absolute temperature, we have 80 plus 460. So kung ato na i-calculate, so 15 over 5 times, so cross multiply padung dito sa kaning nga equation, ang kaning absolute temperature 80 plus 460 all over sa 5. So makuha nato ang temperature 2 or the final temperature of this process. So we have 1620 degrees Rankine. And then sa B, So, ang gipangita isang change of enthalpy. So, in order to get the value of mass, so we have to perform a ideal gas equation of state. So, we have this formula. P1B1 is equals to MR T1. So, we have 15.5 na pressure. PSI A, LB per inch squared. So, para ma-balance ang atong unit, so dapat in terms of feet siya tanan. So we have this 144 times 5 cubic feet is equals to mass times R nga 96.2. So nasa given nga gas constant times sa absolute temperature. We have 80 plus 460. So we can get the value of mass. We have 0.2148 pounds. So now we can get the value sa change of enthalpy. We have MCP T2 minus T1. So the mass is 0.2148 and then the CP is 0.529 in a given problem. Yan ang state. And then sa temperature 2 is we have 1620 minus 540. So the value of the change of enthalpy is equivalent to 122.72 BTU. And sa C is a change of internal energy. In order to get the value of specific heat constant volume, so we have this relation between these properties. We have R is equal CP minus CB is equals to R. So na naman tayo given nga constant pressure, specific heat constant pressure. So we have 0.529 minus CB is equivalent to 96.2 over 778. So in terms of BTU, tanan niya. Yang gi-balance ang unit. In terms niya og BTU tanan. So we can get the value of specific heat constant volume. We have 0.4053 BTU per pound Rankine. So magamit na nato ang or ma-perform na nato ang formula sa change of internal energy. So we have this 0.2148 times 0.4053 times 1620 minus 540. So the answer is 94 BTU. So ato i-recheck. 0.2148 times 0.405 times 453 times 1620 minus 540. So the answer is 94.02 BTU or estimate for 94 BTU. So for D, so gipangita is ang change of entropy. So we have this formula is equals to MCP ln T2 over T1. So the change of S is equivalent to 0.2148 na mass, nakuha na nato ganiha. And then the CP is 0.529 ln 1620 over 540. So we can get the value of the change of entropy. So we have this value 0.1248 BTU per Rankine. And sa E is ang work non-flow. So we have this formula P V2 minus B1. So para in terms of feet LB, so we have this. So ato multiply in terms of feet squared na. So mahimo na siya og LB feet ang result sa iyahang unit. So 15.5 times 144 times 15 minus 5. So the answer is 2232 2232 feet LB. But in terms of BTU, so we have this this value 28.7. So I'll check. So 22320 divide 778. We have this value 28.69 or 28.7 BTU. So now let us move to isothermal process, or we call it constant temperature process. So an isothermal process is an internal reversible constant temperature process of a substance. So an isothermal process is a thermodynamic process in which the temperature of the system remains constant. So in mathematical form, the temperature is T is equals to constant. So the heat transfer into or out of the system typically must happen at such a slow rate in order to continually adjust to the temperature of the reservoir through heat exchange. In each of the states, the thermal equilibrium is maintained. So as we observe this image, uh, isothermal. Okay. So as we observe this image, in order to maintain this the temperature, if we apply a heat, so dapat i-increase na to ang volume while nag-decrease pud ta sa iyahang pressure. So para ma-maintain ang iyahang temperature. So not necessarily nga ang ato ang kung moingon tag maintain constant temperature was a heat. So nagyapoy may tabo nga heat in terms of sa iyahang work ani or the work non-flow. So na may moving boundary sa iyahang kaning nga body. So maka-create gyapon tag heat in terms of work. So kung if we apply first law of thermodynamics, so the Q ani is equals to work non-flow. So kung ato na i-describe in terms of diagram, we have this pressure volume diagram. So mo ni may tabo no. We have this point, initial point 1, and then the initial point 2, we have PdB, and then the TS diagram, or temperature entropy. So we have this initial point 1, initial state, and this we have final state pod sa kaninga process. So we can create the gihapon no. So we have this change of S. So we can create a heat. So in relation between P and V, so we have in accordance with the Boyle's law na equation, so we have this equation P1B1 is equals to P2B2. So the non-flow work, we have this integration of PdV. So where PV is equals to C sa mo ni ang gi-state sa Boyle's law, di ba? So ang PV nato is equivalent is equals to constant. So kung ato ni kung ato ni divide both side of volume, so ang iyang pressure is in terms of C over V. So kung ato ni substitute, so mo na yang ma-form sa iyang equation. So mahimo na siya og integration from 1 to 2. So CdV over V. So the integration of dV over V is equivalent to ln V, di ba? And then upper limit minus lower limit, so mo na yung mahitabo. So ln V2 minus V1, ln V1. So by simplifying, so mahimo siya og ln V2 over V1. So we know that the constant this constant is equivalent to pressure and volume, or we can rewrite this form to P1 V1 ln V2 over V1. Okay? So the work done flow is equals to P1 V1 ln V2 over V1. And then the change of internal energy, we have this. So change of U. So we can conclude that change of U is equals to 0 kay ngano ang ato ang temperature is remain constant raman, di ba? So kung mo-apply ta tong formula nga mcv is equals to T2 minus T1, so ang ilang temperature is the same raman. So kung ang T2 minus T1 is mahimo na siya og 0. So ayan, change of internal energy is equivalent to 0 gyapon. So the heat transfer, so Q, kung if we apply first law of thermodynamics, so Q is equals to change of U plus work done flow. So atong change of U is equivalent to 0 man, so it will cancel this. So ato ang work done flow is P1 V1 ln V2 over V1. So the same as work done flow ra gyapon ang formula sa Q. Then the change of entropy, so equivalent to 0, which means kung mo apply ta tong formula nga MCP, T2 minus T1, so ang ilang temperature is the same man, so ma-0 gyapon ang iyang value. And then the change of entropy, change of H, 2 over T. So we can say that ato ang Q is MRT ln P1 over P2, so the same as sa B2 over B1 na gyapon, no? So by using Boyle's law nga equation, so pwede nato i-rewrite into form ang kaninga form, pwede na ma-rewrite into kaninga form. So nakulangan ni siya og temperature, no, dapat MRT ni siya ln P1 over P2. So sa change of entropy mao ni siya MRT ln P1 over P2 over T. So cancel the temperature, kay the same raman na sila og temperature, di ba? So constant temperature man. So ma-cancel na siya. So mao na niya ang iyang form sa change of mathematical form, or the equation of the change of entropy. For the steady flow isothermal, so if we apply first law of thermodynamics, so mo na mahitabo. So work steady flow is equals to the change of H is makancel naman, di ba, kay equals to 0. So the Q, work steady flow is equals to Q minus change of P minus change of K. So if we assume that the systems is nang walay velocity, no velocity, and no elevation, so the change of kinetic energy is equivalent to 0, as well as change of potential energy. So the Q is equivalent to work steady flow. And then the work in B, the work done flow is equivalent to work steady flow. So let us have an example. So sample problem number 1. So during an isothermal process at 88 degrees Fahrenheit, so the pressure on 8 pounds of air drops from 80 psi or pounds per inches squared to 5 psi for an internal reversible process. Determine A, the PDB or the work non-flow process, and B, the negative VDP or the work steady flow process during which change of key is equals to 0, and then the C is Q, and the D is change of U, and change of H, and E is change of entropy. So sa A, we have integration of PDB. We have this formula nga ato na came up ganiya sa pag-derive. So we have MRT ln P1 over P2. So mass, we have 8 pounds, R nga 53.3, and the temperature, the constant temperature is 88 plus 460 over 778 in terms of BTU na siya, ln 80 over 19.7. So the answer is 41.2 BTU. So sa B is work steady flow is equivalent to work non-flow. So the answer is 41.2 BTU. So at sa atong gi-derive last time. So sa Q is equivalent to change of U plus work non-flow. So sa kaning change of U is equal to 0. So makancel ang change of U nato. So the Q is equals to work non-flow, or the heat is equals to 41.2 BTU. And the change of U and change of H is equals to 0. So walay kanang changing or increasing sa nga nahitabo sa internal energy and then sa enthalpy. So sa A is the change of entropy. So we have this formula. 41.2 BTU or mao na yato nakuha nga heat gikan ani nga sa B or sa sa C nga kuan value, we have 41.2 BTU over the constant temperature, we have 88 plus 460 in terms of Rankine na siya. So the value of the change entropy, we have this 0.769 BTU per Rankine. So that's all for now, and have a good day.